Okay, this is the sixth video for the semester review. This is problems 52 through 60. So suppose 80% of jurors come to a just decision. In a jury of 6 people, what is the probability that at least 4 come to a just decision? First off, we have a fixed number of trials, which is 6, and we have a probability of 0.8. This means I'm working with a binomial. Okay, and so I'm going to make my number line 0, 1, 2, 3, 4, 5, 6. And it says in a jury of 6, what's probability at least 4? So 4, 5, 6 are what I'm interested in. But we also have this phrase at least, which means 1 minus, and anytime it's a at least, it's going to be a CDF. So 1 minus the binom CDF. Trials is 6. Probability is 0.8, and our X value, we always subtract out what we don't want. Be really careful with that. Subtract out what you don't want. If you wanted a 4, don't subtract it. You don't want the 3, so 3 is our X. So trials, probability, and X. So here we go. 1 minus second vars, binomial CDF. Sure enough, it asks for my trials, which happens to be 6. My probability is 0.8. In this case, my X value was 3. And we get 0.90112, which in this case shows up as letter D. All right. Number 53. The problem of obtaining a head when a certain coin is flipped is about 0.65. So here's our probability. Which of the following is close to the probability that heads would be obtained 15 or fewer times when the coin is flipped 25 times? So here's our trials. All right. So let's make our number line. And by the way, since we have a fixed number of trials, we know we're working with a binomial. I don't see at least, but let's go ahead and make our number line. We could have 0 head, 1 head, 2, ... 1 below the interest, 1 above, ... all the way up. So it says would be obtained 15 or fewer. All right. So that means I went from 0 to 15. Any one of these are 15 or less. 14's less, 2's less, 1's less, 0's less. Notice I circled 0. If I circle 0, then I'm not going to have to do a 1 minus. So this is going to be a binom, but I do have multiple values circled, so this makes it a CDF. The trials in this case are 25. The probability, 0.65. And the X value in this case is 15. That's the highest value we want. So trials, probability, X. So I should be able to just plug that in as a binomial CDF and not do very much with it. So second vars, binomial CDF, trials, 25, probability, 0.65, X value, 15. And I end up getting 0.369, which is pretty close to 0.37. So 0.37 is my best answer. So we'll go ahead and circle letter B this time. A person has a 10, this is number 54. A person has a 10% chance of winning the daily office lottery. What's the probability she first wins on the 4th day? Okay, we have a probability, but we also have the word first. As soon as they say first, I think geo. And so I make a number line because we have the 4th day. So 1, 2, 3, 4. She wins on the 4th day. Since I'm only circling one number, this makes this a PDF. All right. Probability 0.10. X is 4. So this is probability X. So second vars, geo, PDF, probability 0.1, x is 4, 0.0729. So in this case, our answer is letter C. Number 55. The average noise level is in bar is 36 decibels with a standard deviation of 5. Assuming a normal, okay, they tell me this is normal. What is the probability that the noise is between 30 and 40? So I need to draw my picture. My picture is this. We have a mean of 36. I'll write my standard deviation off to the side. A lower value of 30. And an upper value of 40. So this is my lower, this is my upper. Because it's normal distribution, this makes this a norm CDF, lower 30, upper 40, mean 36, standard deviation is 5. Once again, all of that's on the calculator, so let's check it out. So second vars, normal, CDF, lower, and by the way, this picture shows everything for us. Our lower part of the shaded was 30, the upper part of our shaded was 40, our mean was 36, and our standard deviation is 5. We end up getting 0.673, all right? And that happens to be right here at letter D. So 0.673, which happens to be letter D. All right, 56 through 59 all have to do with the table. All right, so 500 people used a home test for HIV, and then all went more conclusive hospital testing. The accuracy of the home test was evidenced in the following table. Well, anytime they give you a table, you should go ahead and total everything. So this is 40, this is 460, and 40 plus 460 is 500. 5 plus 435 is 440. 35 and 25 are 60, and 60 plus 440 is 500. So everything seems to sum up correctly. Okay, so what is the predictive value of the test? That is, what is the probability that a person has HIV and test positive? This doesn't say anything about given, but it does have the word and. So we're looking for HIV intersect positive. So has HIV is right here, test positive is right here, so 35 out of 500. So 35 divided by 500, and this is 0.07, which is letter A. What is the number 57? What is the false positive rate? That is, what is the probability of testing positive given that the person does not have HIV? So anytime it's a given, it's always going to be intersection over the given. All right? So does not have HIV. So who doesn't have HIV? 460. So that's going to be my denominator. And we're testing positive. So we need the intersection, because remember it's intersection over given. So the intersection of healthy and positive is 25. So this will be, in this case, 25 over 460. Once again, the intersection, healthy and positive, is 25, and it was given that they were healthy, so the given's always in the denominator. So we have 25 divided by 460 equals 0.054. Our answer is the closest to that is letter A. So 543, letter A. I'm going to pause this for just a moment. Okay, I just copied this chart down on a separate sheet of paper so that I can always have it next to me when I'm doing the next problems. So basically, we still have HIV 35, 5, and 40, healthy 25 tested positive, and 435 tested negative, which is 460. So basically, I just made the same chart that we have above on a sheet of paper. Okay, so what is the sensitivity of the test? That is, what's the probability of testing positive given the person has HIV? Once again, anytime they say given, I know I'm going to be intersection over given. And what were we given? We were given that they have HIV, has HIV, and we want the intersection. So let's look at this. Well, how many of them have HIV? In this case, 40. The intersection of testing positive and HIV is 35. So in this case, we're looking at 35 over 40. Is 0.875. So in this case, our answer is letter E, because that's 0.875. 59. What is the specificity of the test? That is, what is the probability of testing negative given, so another, that the person does not have HIV. So given, and anytime you have a given, you have to have an intersection on top. So intersection over given, and our given was not HIV. So how many people did not have HIV? Well, it turns out 460 of them were healthy. 460 were healthy, so that's our denominator. And the intersection of healthy and testing negative is 435. So this is going to be 435 over 460. So 435 divided by 460, 0.946, which happens to be letter E. Okay. All right, number 60. This will be the last one for this particular video. The mean income per household in a certain state is 28,000 with a standard deviation of 8,500. Assuming a normal distribution, 95% of all households have an income over what amount? All right. This is a tricky problem, and I don't think it'll be on your final, but I'm going to show you how to do it anyway. The mean income is 28,000. And I drew the normal curve because they told me it was normal. The standard deviation is 8,500. And here we want 95% have an income over what? All right. So that means I'm shading from this. This has to be right here, has to be 0.95. And I happen to be looking for this value. There's a thing on the calculator called inverse norm, but it works left to right. All right. So 1 minus 0.95 is 0.05. And if I do that, second vars, inverse norm, area is 0.05. The mean was 28,000. And the standard deviation is 8,500. I end up getting about 14,000. I know it's rounded differently, but that's my answer that's closest. Now, realistically, I don't think this will show up on your final, but if it does, you now know how to do it and you know what the answer is. All right, that concludes this video.